Good afternoon, eCognition fans. This is Keith Peterson, the Trimble eCognition Product Manager, coming to you live today from the mountains of Western Austria. So I apologize ahead of time if the internet connection is a little weak. It could be because of my location and weather. It's not necessarily you. Today we have an excellent topic. We're squeezing in our July webinar just here at the end of the month to introduce all of you to what is new in eCognition version 9.5. But before we get started, there may be a few new listeners on the line today, and I just want to give you a brief introduction, as always, to our Trimble eCognition software. But before I even jump into the introduction, I would just like to mention that this webinar is being recorded. So if you miss anything during the webinar, you can access the recording either within our YouTube channel, eCognition TV. You'll see all our webinars are posted there within a few days of the live event. And also, you will notice you're all in listen-only mode. That's intentional, but you have the ability to ask questions to us today through the question dialogues that you have in the GoToWebinar interface. I have assisting me today Christian Beise. He is our market manager, so he will be fielding the questions and also providing some questions to me. So please feel free to ask a question at any time during the webinar. We will interrupt the webinar to answer a few of the questions and of course have some question and answer after the webinar. So those are the rules of the webinar, if you will. Now to the introduction. What is, say, eCognition for anybody that's new on the line? Well, as nothing changed since the last version, we still are now advanced analysis software for the creation of geospatial applications. So what we're really trying to do again is take that real world, how it's represented in either image data, elevation data sets, whether they're rasterized or point clouds, and we want to take these great data products and turn them into information. So it could be a land cover map, impervious surface mapping, looking at individual objects in the landscape, so maybe picking out individual trees or cars, mantle covers, things of that nature. We want to turn these geospatial data products or data sets into beautiful information products that you can then go and use in a GIS or other types of applications. Right? So what we are enabling users to do is to create their own extraction or change detection solutions to transform this geospatial data into geospatial information. Okay. We can, of course, extract information from our imagery or our point clouds in combination with vector layers, but we can also update certain layers. So we can update those existing vector data sets that get outdated as soon as the new flight campaign comes in with information such as building changes, road network changes, things of that nature can then be reflected and added to these cadastral data sets. One of the greatest strengths of eCognition and one of the real features that I love when working in this software is the topic of geospatial data fusion. What do we mean by this? Well, eCognition can, of course, support raster imagery, but we can combine this with our vector data products, with shapefiles, file geodatabase information, and we can even combine these with point cloud data sets. That point cloud could come from a photogrammetric point cloud data set. Doesn't really matter as long as it's in a LAS or LAZ format. So LAS, LAZ formats, where it comes from, doesn't matter. It can be something from an MX9, a terrestrial scanner, UAV, airplane. That's all up to the user. But the real strength is being able to combine the different elements, different characteristics of these three data sets and fuse them together within the rule set, within that eCognition workflow to create a more robust description of what we are seeing on the ground, okay? So that being said, let's get to the topic at hand today. Highlights in version 9. We just released this at the middle of the month. So we're really excited to have this out. It's what we're calling a productivity release. This means that we really focused on improving productivity efficiency and tools meant to streamline, make things faster for processing and development within the software. First of all, we have boosted point cloud operability. What do I mean by that? Well, we've added a new point cloud resampling algorithms. This really increases the processing speed by reducing oversampling in dense regions of our point cloud. We have then enriched data fusion capabilities by now allowing our 3D viewer to support not only the point clouds and the vectors, 3D vectors, of course, but also the raster layers can be displayed in this viewer. So we can really see all 3 of those data sets within a 3D viewer that are supported within our project. On top of this, we have improved deep learning performance. For those of you that are new or maybe haven't even seen the deep learning algorithms in eCognition, yes, eCognition combines the strengths of deep learning with object-based image analysis, okay? I really stress combine. That is the strength here, not just doing solely deep learning, but combining deep learning with object-based image analysis techniques within Developer. What have we done? Well, we've extended our algorithms to support batch normalization. This will help speed up the processing of various elements in the application of deep learning workflows. And we have new advanced sample manipulation tools that really help automate the production or automate the use of deep learning within production workflows. So we can merge and split sample spaces, for example. On top of this, we've extended our vector OBIA support. We have done a lot to support regions within vector algorithms, with clear performance benefits in terms of how we handle our vectors, or even how we can handle the data based on information that's stored in our vector files. We have new features and algorithms to allow more flexible processing exclusively on that vector domain. And of course, it's also possible to calculate statistics in the vector domain to shrink polygon vectors, or say apply a negative buffer, if you will, and to access layer values and object class information within a vector domain. I'll try and point out some of these as we get further along. I've set up 2 demonstrations that I will hope show some of the real nice features that we've just covered briefly here. To go into a little bit more detail, this boosted point cloud operability. So beyond some of the new features that I just mentioned, here's actually a screenshot of what we're seeing here. We can see that the point cloud is overlaid with the raster within the viewer, but we also have new items here to create a temporary point cloud. This performance has been improved within this algorithm by restricting the analysis to the bounding box of the point cloud itself. Okay? You can also compute statistical values from the point cloud. Now, several values can now be computed at once. You don't have to do it one at a time. Obviously, faster and streamlining our rule set development. We can also assign a class to the point cloud, and this also can now support multiple classes at once. And really, my favorites within the rasterized point cloud algorithm is we can now create several rasterizations at one time within the algorithm. So we can define to extract several raster layers from point cloud features within a single algorithm. We don't have to add an algorithm for each one of those features that we want to extract as a raster layer. So these are really just great ways to improve rule set development and streamline our rule sets. Within the deep learning, like I mentioned, we introduced batch normalization, really a technique for improving the speed, performance, and stability of neural networks. This is now a user option within the creation of the CNN. We'll take a look at this in the actual rule set later. You'll see the option yes or no, whether you want to do this or not. But more beyond that, we have algorithms to delete sample space. So sample spaces. Deep learning is based on lots of samples, so these sample spaces can take up lots of disk space. And of course, when we're done with a sample space, you may just want to be able to delete it. get back down to your disk space. We can split the sample space. We can merge the sample space. These are all really good automated options that will improve deep learning, or the application of deep learning, particularly in production environments. Now here are the details of extended vector support. Right, so we have the region support. We calculate and can shrink vectors, but again, we have a whole host of other new algorithms, new features. For example, classified as at the vector. This feature allows you to test for the existence of an image object class at the location of a vector, really speaking to the data fusion that is possible. The vector buffering algorithms have been improved to now support pixel units, not just geo units. This is a real nice one to have. And you also have PPOs available for the vector domain. This means that a feature will test whether a domain vector overlaps the vector in the domain of the parent process. If you're new to eCognition, that's probably a mouthful. It's a really effective tool, very strong use of parents. These PPO techniques. We also have within the update region, we've improved this now to as an option from domain. This will then allow you to set the region exactly to include a vector or image object domain. Within vector processing, we can now restrict this to a region. Again, faster processing time. And another real nice one here, we can calculate the layer pixel value at a vector point. So this feature returns the layer pixel value of a user-defined layer at the location of a point vector that you may have brought in from GPS, a ground truth data, for example. That's also a very nice one to have. That's not all we've done. There is more, so please take a look at the release notes. You'll get a wonderful overview of all the new features, improvements that have been added to version 9.5. This release note document is available directly through the help menu within developer. Just go to help, online documentation, and you'll be able to jump right to these release notes. And I recommend taking a look at this so you can quickly get up to speed to see how certain algorithms have improved or have changed in from going from version 9.4 to version 9.5. Just to pick out a few, I just went in and took some of my favorites off the top list. There's a new option to remove all temporary layers or all image object levels. No longer have to create an algorithm to remove each single layer or each image object level that you may have. That's a real time saver in development. We've also extended index layer calculations. So we have the possibility of this within layer arithmetics, but in the last version, we also introduced a couple of quick index layer calculations through an algorithm, and we've expanded this to now include the enhanced vegetation index, so that EVI, normalized difference snow index, NDSI. So we have two NDSIs now, soil and snow index. Be careful of those. I hope people living in the northern reaches of the world appreciate this new tool. We also have the soil adjusted vegetation index, so that's SAVI, S-A-V-I. And there's also a green-red vegetation index. So if you're lacking that near infrared, you can still try and use this GRVI to look at and extract value information on vegetation. Also, in terms of segmentation, we improved the watershed segmentation algorithm. This now has the ability to overwrite image object levels, so you don't have to delete the image object level before you execute the algorithm again. It will simply overwrite the existing image object level. And by default now, all image objects created within the watershed algorithm are what we call connected objects. Those are some of the highlights that I've pulled out of this document to present here today. But again, please read through, and you can get all the information in a quick tabular format, as you can see. So to summarize, eCognition 9.5 adds a real series of tools, features, improved tools and features as well to improve productivity. Productivity really is the key word here. again, boosting the performance and increased data fusion. We have the raster point cloud fusion tools and the 3D viewer, batch normalization support for deep learning, as well as some of those great sample space operations, point cloud resampling algorithms, region support for vectors. These are some real time savers in terms of processing. And I hope you really enjoy these features and we can accelerate your analysis. So ordering, availability, and resource. Well, when did 9.5 get released? If you missed our announcement, we released on the 12th of July here, 2019. If your software is under a current maintenance contract, you would have received the entitlement email with the notification and access to download the software. Here again is the address. So if you have the valid login information, you can access our downloads portal and grab this. If you want to see how this works, if you're on the fence about your maintenance, you can test out the free trial. It's available online. You can go in and you can test all this functionality. Okay? It's all available there. Other questions, visit the eCognition community. We have over 16,000 registered user accounts now. So it's an active area. There's a lot of discussions going on. And if you have questions, post them there, and hopefully people will reply. So Christian, before I move into the demonstration part of the webinar, are there any questions from the audience?
Not yet currently. No specific question to the new features, but there is a question. It's a general one. How we will get the full version of the software? I can answer this, or you answered this some minutes before with the download portal. If you have a license, if you have already got the entitlement email, inside this email there's a link to the download portal where you can download the software, or go just to www.ecognition.com, and then you will find also the link to download the full version of the software. But to use the full version, you need a license for version 9.5, of course. If you have any issues to get the full version, please contact us via this support, please. That's all currently, Keith.
Excellent. Okay. That means everybody knows exactly what I just talked about, and they will pass the test at the end of the webinar in flying colors. That's a joke. There is no test, but just enjoy now the demonstrations. We will we'll sort of visualize what I have just been talking about, and hopefully then you'll get a better understanding of how these new functions work within the software. So I prepared 2 demonstrations. The first is really showing some of the improvements we've made to viewing data, working with data in eCognition. So we'll take a look at some of the new functionality available within the view setting dialog, as well as how we can fuse raster and point cloud data displays together in the 3D viewer. After that, we'll take a look at some of the new vector tools, particularly these vector shrinking within the context of deep learning, so within the context of our convolutional neural network sample patch generation. And then we'll also take a look at some of the deep learning algorithms, some of those new algorithms that are available for really automating your production workflows. Okay. So we'll come back to the presentation. Now we are going to jump into the eCognition software itself. The first one I want to show is actually this image here. This is eCognition 9.5. Shouldn't look radically different from a user interface perspective than 9.4, but we have made some nice improvements that I can point out immediately here in the view settings dialog. This view settings dialog helps you manage the view, what you're looking at, and how you can interact with your data. First of all, you can change your layer aliases now directly from within this dialog. So you can simply double click on a default layer name, layer 1, and I can give this a new name. I'll type in here red, for example, and that is now updated across my project. We can also shift layers directly from within the view settings dialog. So you no longer have to go to the source view dialog to do this. It can all be done simply from the view settings. So I can essentially drag and drop a layer right within this dialog, and it will shift its position in the, see there's a slight lag there in the display, but now I've changed the position of these two layers here. All right. So we'll just bring a layer to maintain our real RGB here. You also see here is I have a point cloud layer loaded into my project here. I see this under the point clouds category. It's currently turned off. So I'm going to turn this layer on now to display it. We see this LiDAR data set here. If anybody is listening from the state of Vermont, my home state in the United States, we are looking at the Capitol building in Montpelier, Vermont, beautiful gold dome, and we can see the LiDAR and in imagery for this here. By default, I'm in the height mode. I can control the point size, the viewing point size with the slider here. And more importantly, as soon as I load that point cloud data, you'll see I have options for doing a 3D display. So I can either click and just create on this 3D subset selection and just generate a very quick subset to view in 3D. Additionally, we can just click up here in the gray area, come down into our toolbars menu, and go into 3D toolbar. This will open up an additional toolbar with some more advanced options for creating 3D subsets. So here today, I'll just show this one. This is a 3-point 3D subset selection. It works. And the way that I defined 3 points to create this. So I'm drawing a line here. There's click number 2, and then I can create my bounding box here. There's the third click. As soon as I hit this third click, we will generate a 3D subset of this area. And as you can see now, this 3D subset includes my raster imagery. And the way we display the raster imagery with the point cloud is simply by snapping raster to the lowest point within my point cloud, within that bounding box that I've created here. So if we look at the profile here, we can see the Capitol building's on a nice hill above this road down here, and it slopes down in the green, so we're snapping down in this region. All right. So that is a nice feature to have. We can gain an understanding of how maybe our LiDAR in this case overlaps with the pixels. You can see there is some offsets between the dome captured in the LiDAR and that captured and displayed in the imagery, but it can also just give us a better sense of what's going on within our point cloud as it relates to the imagery. Okay. Beyond this, I'll just take the opportunity while we're here in this setting here, we can go into the process tree. I'll do an append new, and we can go into that index layer calculation algorithm. And you can see here, within this, I can select now from a number of different indices that I want to calculate. So not only those that we had before, but the new ones have been added here as well. And to differentiate between snow and soil, snow is with the little n here, so NDS little ni, and we also put in parentheses behind a slight indication of what this indice is calculating. Christian, any questions to the point cloud display with our imagery?
Unfortunately not. But there is a general question, maybe for someone who comes a little bit later to the webinar. There's a question if the webinar is recorded, and I would answer this here directly. You did it also already. Yes, the webinar will be recorded and available in our YouTube channel, eCognition TV, in a few days. And you will get also a link directly to the recorded webinar after the event. That's all currently.
Correct. Okay, excellent. All right, so that was this first example, just looking at some of the new features to the view settings, as well as some of the 3D viewing capabilities available within eCognition Developer now. So now I'm going to jump to a different project. This is some imagery, I believe, from Berlin, Germany, where we have a workspace set up here. So we have multiple projects, multiple tiles, if you will, loaded into this workspace. And we've also have a rule set loaded. And you can see the first part of this rule set is all about creating samples. So what this rule set is looking at it's a deep learning rule set, so we're going to create sample patches within this rule set, and I will then explain, because the processing, deep learning, it takes processing time, and unfortunately we don't have time within our webinar slot to handle all the processing. But what this rule set is really doing is looking to identify, we're trying to train and identify cars and along the streets here. So first part of this is now, first of all, we're loading our ground truth data. So we have to create samples, and we have some samples created already. So I'll just execute this patch here. You'll see now that a vector is loaded. That's been done through the create modify project algorithm here. And that's another new feature of 9.5 is that we have a nice icon here for our vector polygon file that will indicate that this is a polygon vector. We'll turn this on, and we can see that these cars have been digitized by somebody. We've painstakingly gone in to generate some training samples. So let's go down, we'll take a zoom in, take a closer look here. I can change these outline colors to something that's more visible if you want. You can do all that directly within the view settings dialog here. So that was just loading our data. The next part we actually want to do is we want to generate these samples. So we're first going to classify car objects, and we can then use those to the creation of samples for our deep learning or convolutional neural network. So the first step here is going to be classify, but right now I have vectors, no image objects. I'm going to do a couple of vector operations I mentioned earlier. This gives me the chance to show the new vector buffering / shrinking algorithm. So that algorithm has a new name. It's now called vector buffering and shrinking. So we can just open this up, take a look at it. Here's the name of the algorithm, the domain, of course. Where is this going to be applied? We're going to apply this to the layer car outlines. And then we come over here, we have different buffering modes. So we're applying a round buffer here as opposed to a miter or a square buffer. And you can see here, I have an offset distance set to 10. This unit is my project unit. So that will be obviously in geo units. If I wanted to use pixels, I can use, say, the pixel unit here as well. I'm then going to create an output called car core. So I'm shrinking this initial buffer to be sort of the core, the real body of the vehicle. So we'll take a look at this, execute it. It goes very quickly, and we can. Oh, sorry, that was meant to go be performed on map 2. Sorry about that. So we're actually down sampling this map. We'll go into map 2. Here we can zoom in again to our location. So we've just downsampled the data a bit, and we're going to execute this algorithm, and voila, here is now my new vector layer added to the view settings called car core, and you can see the effects of this this new shrinking that's gone on here. All right. The next thing we're going to do is just another buffer operation. This time we're actually going to be creating a buffer as we know it, not a negative buffer. So you notice to get that shrinking, we initially applied a -10. So that was we have to put in the negative symbol there. Now we're going to grow this, but we're going to create a mitered buffer instead of a round one. And we can also control the limits of that miter. And now we're calling this new layer car surround. We'll see why we call it that. And so that's this new layer here. So this not only contains the car, but it also adds a bit of context, a few context pixels of out and around the particular vehicle. Okay. So these are now can be used as input for the samples in our CNN. And what we're going to do is now take these from a vector object and create image objects from them. So we're using a relatively new algorithm. This came out in 9.4. The vector-based segmentation simply allows us to cut out our vector layer and convert those vector objects to image objects. I'll take a look at the results of this for you as well. And it should be done soon. A few seconds remaining. There we go, creating the objects. A lot of cars here to cut out. So this will allow us to then, once we have the vector objects, we can then classify, we can use our object-based image analysis techniques here. So I'll turn off the vector layers. As you can see, I off each individually. I can hit the whole group, come in here, and we can see that we cut out the different vectors that were within the project. Okay, as a user, you can define which of these to cut out. Next, we're using a threshold-based segmentation. We're simply going to be, if we zoom all out to extents, you'll notice that there's a lot of background pieces here. We're just we want to exclude this from our analysis. So we're simply going to throw this into a class called background and using simple layer threshold to do this here. Take a look at those results, turn on the classification here so you can see this has been put in a class called background. All right. The next thing we want to do is actually those are objects that are a car to a class within eCognition. So we're simply going to do this with a overlapping number of overlapping objects feature here. So we're saying if it overlaps with a vector object, it's going to be considered a car. We can run that and we'll zoom in and take a look at those results for you. Where was that little area with the parking lot? Here we go. And now you can see that I've just taken that, I'm only considering this a car object if it overlaps with that car core vector that I created. All right, we're going to do another overlap classification here, and this time we're going to look at this at whether it's overlapping the surrounding area. So we have our car class. We also have our car surround class now that we've derived from those initial vector objects. Everything else that's unclassified now, we have lots of unclassified image here, is going to go into a class called other. That's what we've created here. So now how does this all work and feed into deep learning and CNN within eCognition? Well, first, take a look at the creating of samples, and we're doing this, we're going to be rotating our map so we can, say, create some artificial samples simply by taking these initial samples and rotating them at a series of angles. We're controlling this rotation in a nice fancy way. We're using an array to do this. We can open that up. So we're going to our manage arrays option here. And you can see here angles. See, they're going to be my rotation angles. They'll be written and stored within an array within eCognition. All right. And like I said, I'm not going to execute this because it would mean we lose time within our valuable webinar time. But what we're doing, we're coming now down into writing this into a map 3. We see now we have several create samples algorithms here. So we'll open up the first one. This is called an algorithm called generate labeled sample patches. You can see here we have type. This is the format that the sample will be stored in. So you can use TIFF or raw here. We have the sample count. So we're going to create 30,000 samples. The patch size is going to be 60. In this case, so 60 pixels. And what layers are we going to create this for? We're going to have 3 layers, so our RGB information here, and we're going to store all our samples within a folder called a sample folder. Okay. We can then do the same here for other samples. So sorry, this is for this was for the car. We use that car class filter here. If we compare that to the other algorithm, this used this was samples for the class other. So we want to not only have samples for objects we're looking for, but also stuff that we're not looking for. And then we do the same. We're also going to generate some samples for this class car surround. Right? And those all get put into the sample folder. So that's how we are generating samples. We're growing the initial number of samples through the rotations. We have those defined rotation angles in the array, and then we can automatically generate these sample patches through these algorithms and store them all in the sample folder. Christian, before I move beyond the creation of samples and beyond the topic of some of the vector operations that we have here, have any other questions come up?
No, there's no specific question to the new features. There were some general questions, what I answered already here in the meantime, how to contact sales and general question in this context, but no specific question to the new features.
All right.
But I recommend if there are any questions, don't hesitate to use the question dialog in the GoToWebinar tool to insert your comments or questions. We would be happy to answer them. Absolutely,
that's why we're here today. So next, I'm going to come into the next section, the next chapter. The rule set. This is all about training. So let's take a look. First of all, we'll make this active. We're going to look at the prepare sample space. Here's where we've added in a lot of those new algorithms to help us deal with sample space, particularly in terms of production. So you see the first one is called merge labeled samples. So I'll just open this up. Now what we are doing, I'll give you some background here within this project. What we have done, we have 5 images here, and we're going to create samples based on 4 of those 5 images, and we're grouping those into sample folders. There's then a sample folder that corresponds to each image. But I also want to be able to merge the samples from various images into a single sample folder. So that is what this merge label sample space algorithm allows you to do. I'm defining the input folder. Where are these samples located? It's called sample spaces. Explain, we've set that up in an array as well. And then here we're going to create a folder called samples merged. All right, so again, go into my manage arrays dialog, and I can take a look. Here is a list of the images, and those are the individual folders. So I'm going to take these individual folders in the sample space array, and I'm going to merge the samples of that content to create a new samples folder called samples merged. Once I'm done with that, I can actually delete the original sample folders because I've just doubled them. I've taken the individual folders and I've merged them together. So really to save disk space, that's the problem. That's why I can't display this live today, as I ran out of disk space while doing this. So each one of these folders I generated was around 32 gigabytes, I believe. So you can see how you can you can run out of disk space rather quickly. So I'm going to delete the sample, the individual sample folders. I've got everything now in that merge folder. The next step here is I'm going to shuffle the contents. I'm going to shuffle those samples, those sample patches within the merge folder. Okay, and that's what the shuffle labeled sample patches will do there. I'll just take the order that they're coming in, and as the algorithm name implies, it shuffles them. From here, we have another one of our new algorithms, this split labeled sample space. So now I'm taking the content of the merged sample space, and I'm going to split it into two groups. You can see here you have various splitting options, binary and multiple. And you can also define the relative size of the samples that go into each folder. So you can see here, very important, the relative size that you define here, this would be 80%, will define the percentage of samples that go into the sample folder defined in the output one field here. So output one, this is going to contain our training samples. I advise giving that sample folder a name that's logical to you, that you know what it is. So here, these are going to be then the samples we use to train our model. And so 80% of these samples are going here, 20% we're going to keep for validation later on. Okay. And again, because what we've done, we've split these samples into two folders, we're doubling the amount of samples now. So I'm going back and I'm going to delete the content within all those samples within the space. Again, saving disk space here, okay? So we'll come down now to the train model section. And here we're defining the various epochs. We're saving these in variables for the model. And what we see here is we're going to create our convolutional neural network at this point. So we're going to create that model. Open up this is done through the create convolutional neural network algorithm. And you can see you have lots of options on how you want to create this model. So here we have our sample patch size. 60 again, we're looking at the number of image layers. So again, we chose layers 1, 2, 3. So we have those 3 image layers. We had what we want is output for various classes for the car surround, the car, and the other. So remember, we created sample patches for those areas that we classify. You can then define the number of hidden layers in the next section. That is up to users here. We're choosing to use 5 hidden layers here. And then the new option within this algorithm is whether to use batch normalization or not. So you simply have the options of, yes, I would like to apply batch normalization, or no. And you can define that here. You then have all the parameters for each one of those hidden layers that you're setting up. So you can see here we're using a kernel size of 7, number of feature maps per hidden layer. Here we've defined 32 in this case, and then for the last one we're using a 5 in terms of the kernel size. We then can also, of course, if you create these models and within another project and then load it, you don't have to create it again. You can simply load that model. So you can just define where that metagraph file and the index file are stored, and you can load that to then apply to another project. This is where the actual training takes place. Then in this section, so we've set up our parameters. We're again we're shuffling now just the training samples here. We're defining various iterations. We want to try and reach we're going to be trying to run this, take a learn rate of 98%. And we can then open up the train convolutional neural network algorithm here. So we're defining again, where are those training samples coming from? The learn rate that was defined here in the variable. So we're just referencing that variable. And we have the training steps that we define in the epoch there. So we can, in this case, we're not defining it within the algorithm, we're referencing a variable. Gives us a little bit more flexibility. And then the batch slice here, this is just selecting the number of samples to use within each training step. So here we're choosing 50 samples for each one of these training steps. Of course, then we can save this convolutional neural network, and then we can also look at convolutional neural network accuracy on, here we're looking at training samples, here we're running it on some of the validation samples, and here on another group of what we call new samples here. And of course, we can then export all these statistics out of eCognition. So that was this demonstration, if you will. Again, I apologize that I haven't been able to run it live because it's just machine learning is processing intensive, and despite our best efforts to make it faster, it's not yet going to operate on my small computer with this input data. But you can get a sense of how we've set up the rule set architecture to accommodate these new algorithms. Really, this rule set is going at productivity. We're using it within a workspace. We're really applying deep learning within a production environment here to locate all the vehicles in our input data set here. Okay. Christian, before I conclude for the day, are there any questions? We could go back, whether before I leave the software, does anything come up?
Yes, there are currently two questions. The first one is, it's a general one. What is your experience? How long the the training for the CNN will take in this case with this amount of samples? Is it a half an hour or 15 minutes or longer? What's your experiences here, if you have one?
That's unfortunately, my machine ran out of disk space before I could complete the training. But I think in some of the merge operations, those are rather timely. It was around 25 minutes. The training may take, again, will really depend on the image size, the parameters of this, and I think we're looking at somewhere between maybe 30, 35 minutes in this case. I'd have to go back and run the actual algorithms.
Okay, thank you. I believe it makes also sense to mention here that if you have an Nvidia graphic card, then our deep learning algorithm is using also the GPU for the training to increase here the processing speed.
Yes,
And
very important.
then there's another question. It's a general one, and I have to say I'm absolutely not sure if it's possible. It's a question if there are some hotkeys available to switch between view layer and classification view. Here I'm not so sure if we have this already.
Boy, that is a good question. I also do not know off the top of my head. We at least haven't put anything into version 9.5 to use a key, but I believe you have, within certain tools options, you can set shortcuts,
Yes,
keyboard shortcuts.
that's
So let me
also.
see if I can find this. It's been a while.
But or in other words, the user who asked this question, please ask this question again in the eCognition community so that we can clarify this for everyone. I believe so. There are some options to insert your own hotkeys to change specific view settings.
I believe yes, here within if you again right click in this gray area, you can come down to customize, select that, and you have a various keyboard commands that you can run through and set up for customizing what options do. So there might be one here, new workspace.
You are on the category file. I think you have to
I'm
go
on the category file. So view, here we go. So we can look at view, setting up different views, feature view, image object information.
I think we should check this.
I think
it should be available.
If it's not, we'll make it a tip of the week. So
That's
But
a
you can
nice
see you
idea.
can control all these different options here via keyboard. You can come into the customize menu, keyboard, and then look at the different categories. And you can see if there's a current keyboard shortcut that's been set as default, or you can select a new one.
Great.
Okay.
There's also a question, can individual cars be labeled? Maybe here, as I understood, yes, of course, you can label also different kind of cars, because each labeling, if you mean this, if you want to classify different cars, like, I don't know, red cars or big cars or buses, differences
All
from
right, so
normal
you
cars.
can start to see here that what we've done is really looking at, say, passenger cars, that the trailer trucks were not included in the initial training data sets. So that could be another category that you add to your training data. You could put it in the same layer, then you could differentiate between passenger car and trailer truck. It simply becomes another class that we have here. So instead of using car, you could have car versus truck, whatever it corresponds to the class naming scheme that you want, and then you can train that CNN to include this class as well.
There are here several questions. I think with the labeling, yes, of course, you can label all kinds of classes, like
Yes.
different trees with different species. There's a specific question for this, or different car types, so that you can train then the algorithms, to distinguish the different cars from the other classes, whatever. Yes, this is possible with eCognition. You have the full flexibility to label, to train such a deep learning approach, and to classify the objects. There's a question if eCognition supports panoramic images, and I don't know exactly about this specific image type, but we can say as soon as the image data are stored in typical file formats like TIFF, JPEG, JPEG 2000, or whatever, then we are able to analyze such kind of images. We can analyze all kind of images, but maybe this panoramic image is a specific, I don't know exactly. Please contact also the support team or us, the product management team, directly, so that we can check this.
Right. We'd have to have a few more details about image specifics.
So that's currently all questions, Keith.
Okay, that's all we have today. Excellent. That will keep us within the hour. I'm going to return now to the presentation. Really only have one slide left for you folks, and we will come back into the display. Oops, that goes all the way to the beginning. I can slide this up.
Keith, give me 1 second. There's a question. What was the resolution of the image data of the orthophoto, and how many bands are used for the analysis?
We used 3 bands for that analysis. The resolution, I'd have to go back into the software and check that out. I can do that here. So we have, where is it? Our source view, very handy here. So we're looking at, looks like we have an unknown. Looks like we might have, there's no resolution listed here, probably because don't have the.
You have to go to map 1, please. Is there a change in the main map?
No, we looks like we've done away with certain location information on this input data.
And under file, modify open project?
We could check there as well. Now we reflect the same information in the source view as that we have here. So this, I don't know if we have geocoding. If we turn the geocoding on, that's the key there. So 4 centimeters was the original.
Okay. And there was also a question, we used 3 bands for the deep learning. If you have 4 bands or 5 bands, we have the full
flexibility. You can use as many input layers as you would like. Yep. So that should get us back to our presentation now. And I will just change my view, hopefully not switch around. And if there are any more questions, I guess we have a few more minutes, so you can, if you can busily type in those questions, and we will try and answer them for you now. If not, I would like to remind you there are other great eCognition resources out there that you can look to get any type of question answered. First of all, you can contact our eCognition support team here, support@ecognition.com. You can go and also go directly into the support portal via our website, ecognition.com, and access the support crew. And they would be happy to answer any question that you might have. We also have eCognition TV. That's our YouTube channel. You will find not only these webinars hosted there, but you'll find a whole variety of very good videos covering different algorithms, different topics that we've created. You can also go into the eCognition community and start to launch discussions there. There's a great tutorial for some of this deep learning within the community, so you can download that tutorial, get a sense of how that works. I will have to say the tutorial is from a few versions ago, so it doesn't reflect some of these new split and merge algorithms that just came out about 2 weeks ago. But still, you can get a sense of how we set up the creation of samples, training, and application of all the deep learning directly within eCognition. So please take a look at those great resources. A few more minutes, Christian. Anything come up? The last question of the day. All right.
Yes,
excellent. Then I hope you enjoy eCognition version 9.5. Remember, if you have an active maintenance contract, you have received all the information to access the software. If not, then please check out the free trial. Go in, test out some of these new functions, and hopefully we motivate you to come back and grab the latest version. So I hope you enjoyed this webinar. If you have any other follow-up questions, like I said, reach out to us at support@ecognition.com, and I hope to see you next time for the next eCognition webinar. Have a good remainder of your day, and enjoy.